Good evening, students. In the last session, I started the topic motion in a straight line. Today, I am going to continue the same topic, motion in a straight line, and we will study more about uh, distance and displacement. We take an example. A boy takes one round on a circular track of radius 7 meter what will be distance and displacement. Now we will see. Suppose it is a circular track and its radius is 7 meter. So distance covered in one round it is equal to, suppose he starts from A and he takes one round on the circular track like this. So distance covered in one round it is equal to 2 pi r. This is the circumference of the circle and you can put the value 2 into 22/7 into radius 7 meter. So this is equal to 44 meter. So this is distance covered in one round on the circular track. And now what is displacement in this case? Displacement, as you know, what is displacement? It is the shortest distance between initial and final position of the object. Suppose he starts from A and so this is initial position. A is initial position and when he takes one round he comes to the same point A, so that will be the final position. So in this case, when he takes one round, he starts from A and he ends one round at A. So initial position and final position are same. In this case, A will be the final position. So since both the positions are same, initial position and final position, so displacement in this case it will be 0. So in some cases displacement may be 0, like in this example. You continuously take a screenshot and you note it. Now we are going to take another example. Now one more example. A farmer takes one round on a square field of side 10 meter. Calculate takes one round on a square field of side 10 meter in 30 seconds. Calculate distance and displacement at the end of one minute 30 seconds. A farmer takes one round on a square field of side 10 meter in 30 seconds. Calculate distance and displacement at the end of distance covered and displacement at the end of 1 minute 30 seconds. So now you will see it. Suppose A, B, C, D, it is a square field and it has side 10 meter. Now first we will calculate how many rounds we take in the duration of this. So number of rounds is equal to 1 minute 30 seconds. This is total time upon he takes one round in 30 seconds. So upon 30 seconds, 1 minute 30 seconds, we convert it in seconds. So as you know, 1 minute equal to 60 seconds and this is 30 seconds. So total time is 90 seconds upon 30 seconds. So this is 3 rounds. So distance covered in 3 rounds is equal to 3 into 4 into side of square, because in one round he will cover 40 meter. So this is 3 into 4 into 10 meter. So this is 120 meter. And as you know, when he starts from A, let, so in one round he will be at A. So in completing the 3 round, he will be at A. So displacement in this case will be 0, because initial position is A and after 3 rounds he will be at A. So initial position and final position will be same. So displacement will be 0. We can take one more example to clear about distance and displacement. Now we will take one more example. A car starts from A reaches to B 90 kilometer away, and turn back on the same route reaches to C after covering. A distance of 20 kilometer. Calculate distance covered and displacement. Number 1, from A to B, and second, from A to C. So this question has two parts. You have to calculate distance covered in first part from A to B, and in second part from A to C. Suppose this is position A from where the car starts, and this is position B, which is 90 kilometer away. This is 90 kilometer, and when the car starts from A and reaches to B, it covers 90 kilometer. Then turns around on the same route and covers 20 kilometer and reaches at C. This is another position of the car. So in first part from A to B, distance covered is equal to, as you know, distance covered is the total length of path covered by a body. So distance covered from A to B. So what is the distance from A to B? It is 90 kilometer. And displacement in this case so to calculate displacement, we will see initial position. So as you know, A is initial position, of the car, and B is final position. So what is the distance between initial position and final position? We can see that it is 90 kilometer. It is the distance between initial position and final position of the car. So displacement in this case will be 90 kilometer. You can see in this case the magnitude of distance covered, this, and the magnitude of displacement both are same. Magnitude means numerical value of the physical quantity. So this is 90 kilometer. So this is magnitude. So magnitude of distance covered and displacement both are same. So in this case, when a body moves in a straight line, every time the distance covered will be same as displacement. So in second part now, we will see from A to C. So first the car goes from A to B and then turn back and reaches to C. This is 20 kilometer. So from A to C, distance covered, this is equal to total length of path 90 kilometer and then 20 kilometer. So this is 110 kilometer. This is distance covered from A to C. And now displacement, we will see what is the displacement in this case. Displacement to find the displacement, what is the initial position? It is A. And what is the final position? It is C. So in this case it will be the final position. C will be the final position of the car. So as you know, displacement means shortest distance between initial position and final position. So this value, which is from A to C, this value will give you the result. So displacement will be this total distance, this is 90 kilometer, and to find this value, subtract this value from the whole. So displacement will be 90 kilometer minus 20 kilometer. So it is 70 kilometer. So in this way, from A to C, the displacement is 70 kilometer and the distance covered is 110 kilometer. Now you can take a screenshot of it. Now let us see what we have learned from these examples about distance and displacement. Number one, what is distance? It is actual length of path covered by an object and what is displacement? It is shortest distance between initial and final position of the moving object. Second point, as you have seen, distance covered never be zero. It can never be zero. In any example, you have not seen that distance covered is zero. So distance covered by any object never be zero. But displacement may be zero. In some cases, the magnitude of distance covered is always equal to or greater than displacement and we can conclude that magnitude of displacement never be greater than distance covered. Distance covered. And last point, distance covered, it is scalar quantity means to describe distance it needs only magnitude, and displacement it is vector quantity. Vector quantity means to describe displacement it needs magnitude as well as direction. So displacement has magnitude as well as direction, so displacement is vector quantity and distance covered is scalar quantity. Now you all can take a screenshot of it. Thank you, students.